Hi, this is lesson 25B, part 2 of 2. Now that we know some words, we are going to put them into some examples, some quick examples. So here we go. Geometric sequences. Here's a big word that we are working with today. In your brain, when you see geometric sequences, you have to think of the word ratio. That means, okay, I'm going to have a list of numbers that have a common ratio. So if you're trying to learn your vocabulary, geometric sequences, oh, common ratio. Exponential growth and decay is something that we've been working with before. They are graphs. I always think of it as graphs. That looks something like this. They are the inverse of the log. But then we also have these decay graphs that look like this. They're not easy to draw on this tablet. But let's try to write some explicit and recursive geometric sequences. If we have the first term that is a sub naught, not surprising, a sub naught is 5, and then our common ratio is -2. So my a sub naught is -5, and my r is equal to -2. Look how I'm organizing my work. Because when I have geometric sequences, this is the most important thing I need. A sub naught and r. So a sub naught, I'm going to say a sub, I don't know what kind of knot it is. Maybe it's this knot. A sub naught, or 0, is equal to -5. A sub 1 is going to be -5 times my common ratio, which is -2. So that's 10. And then a sub 2 is going to be my previous number, 10, times another -2. So find the recursive formula for this sequence. And remember, the recursive formula is it calls back the previous term. So if we have a sub naught, well, that's going to be our ratio times our previous term. This is how you write in this notation the previous term. All right, the previous term. But this is how you write it. Whatever your, can you guys see orange? Whatever your term is, a sub n, it's the one before it. A sub n minus 1. That's what a previous term is. A sub n minus 1. And that's going to be your recursive formula, because recursive means you call back the previous one, which is awesome. But let's try an explicit formula, because most of you are just like, let's skip to the explicit formula because this one will help me more. This is going to be your formula, is going to be your starting a value, a sub naught r to the n. Ooh, very important, this guy. So let's try this. A sub n, our a naught is -5, our ratio is -2 to the n power. No, you cannot combine this to be 10 to the n power. Don't do that. So let's try this, a sub n. I don't know how to make my a's and my n's look very different. Let's use this formula, but plug in 9. 9. 9. When you do this in your calculator, 2 to the n power times -5, you're going to get 2, 5, I think 6, 0. I did it earlier and I can't read my writing. I forgot to define this up here. Define n. You have to think, when is this okay? When n is greater than or equal to 0. This takes some practice. We can talk about this in class. Okay. When is term a sub 9? We did a sub 9. A sub 10 is going to be the same thing. If we have -5, -2 to the n, a sub 10, we're just going to plug in 10. Isn't that handy dandy? -2 to the 10. Oh, that's a 10, not a 16. So what you have to do first, your order of operations, you have to do 10 to the -2 power. No, sorry, -2 to the 10 power times -5, and you should get a negative number. because this is an even power times another negative, so there's an odd number of negatives. Okay, number 2, this is our second problem. What is the term A4, A sub 4 of a geometric sequence is 5.8564, and the term A sub 5 is negative 6.44204. What is the common ratio R? To find R, take any term, the bigger term, R plus 1, N plus 1. Take the bigger term, whatever they give you, divide it by the smaller term. Because if you have a sequence of numbers, you are going to have, the ratio is when you divide them. So all you have to do is divide the later term with the previous term. And this is going to be negative 1.1. Ooh, so this is our R value. R is equal to negative 1.1. This is going to be very, very important in our geometric sequence. So what is A sub naught? Well, okay, so A sub 4 is going to be A sub naught R to the 4 power, because this is our geometric sequence formula. Our geometric sequence formula. Sequence. Formula. A sub naught equals A sub n is equal to A sub naught R to the n, right? So we plugged in 4. We know what A of 4 is. It is 5.8564. And we don't know what A sub naught is. We're looking for A sub naught. We're solving for A sub naught. We know what our ratio is, and we know what n is. So when you solve this, you can just divide by negative 1.1 to the 4th power. Divide by negative 1.1 to the 4th power. And you're going to get A sub naught. This decimal divided by this decimal is going to be, what did I get? What did I get? I didn't actually solve it out, but it's equal to this. Sorry, folks. I didn't solve it out, but it's going to equal to this in decimal form. Did I not solve it out? I guess not. Okay, so let's write a recursive formula for this sequence. A sub n plus 1 is equal to the A naught times negative 1.1. So our recursive formula needs to call back. So this is actually not A sub naught. What am I doing? This is A sub n. This means whatever number I choose, the one before it times negative 1.1 is going to be the number I want. So if this was A sub 5, this would be A sub 4 times negative 1.1, which makes sense. But many of you are only going to use the explicit formula because you find it more useful, except when you get into like coding, computer science. Then you're going to work a lot with recursive formulas. So we have A sub n is equal to, we need the, this one, A sub naught has to equal to 4. Do we need this one? We need to define it. A sub n is equal to 4 negative 1.1 to the n power. This we already did up here. This is just A naught. This is R and to the n power. This is just the explicit formula of this geometric sequence. All right, these were our examples. Write your summary here. Bye.